So what I would like you to do is on the back of the guided practice, we are going to start with some example problems that we are going to write down at the bottom. The first one being the square root of 25. The theme of this chapter is all radicals, all square roots, and how we simplify them. Now, if you still have your perfect square sheet, it should either be yellow or purple. You can take that out. Otherwise, it is posted on Canvas in our new module for this unit. So if I want to simplify a square root, we want to look in the perfect squares column. Now, 25 is a perfect square. So what's the square root of 25? It's 5. Yep, we're doing it on the back at the bottom of the guided practice. Number 2. The square root of 45. Now, is 45 a perfect square? No. Does it have any perfect square factors? Yes. What's the biggest perfect square I can take out? 9. So it's kind of like we're doing a little factor tree. We're just multiplying those two radicals together. So radical 9 times radical 5 is radical 45. Now, how we simplify it is the square root of 9 is 3. So 3 radical 5. Now, what's super zazzy about this is though your calculator won't simplify radicals for you, you can verify that this answer is the same as this simplified answer. So just like 2/4 is the same as 1/2, the square root of 45 is the same as 3 radical 5. So what operation is going on between that 3 and that radical 5? Multiplication. So when I break up the radical into kind of factor tree factors, they are joined by multiplication. So the coefficients in the radicals are joined by multiplication as well. Numero 3, the square root of 40. What's the biggest perfect square I can take out of 40? No, put it on the floor. I don't want to see it. 4. So square root of 4. Square root of 10. So 4 is my perfect square factor. Square root of 4 is 2. So 2 we're at 10. So folks, big picture idea, what we're trying to do with these radicals is we are trying to split it into something that is a perfect square and whatever is left over. So if I was looking at 40, why would I not want to break it down like this? 8 times 5 does give me 40, but what's not great about either of those? They're not perfect squares, so it doesn't lead to any simplifying of the radicals, so at least one of them has to be a perfect square. That's how we break it down into smaller numbers, and that's the whole goal. Number 4, the square root of 32. Careful of this one. This one used to always trip me up when I first started teaching Algebra 2. What's the biggest perfect square I can take out of 32? Bigger! 16 is the biggest. So I want to show you what happens if we don't catch the 16 right away. If I just say 4 and 8, the square root of 4 is 2. And that leaves me with 8. But are there any perfect square factors I can take out of 8? Yes, we can take un otro 4, another 4 out. So breaking this 8 down into 4 and 2. So then I get 2 times square root of 4 is 2, radical 2. I will know I am done simplifying once there are no more perfect squares that I can take out of the square root. Now, it's more efficient if we do 16 and 2, because that takes me directly to 4 square root of 2. So if you want to take out a bunch of little perfect squares, you can, but it's most efficient to take out the biggest perfect square. So this is great. This is okay. It works, but it's not the most efficient thing we can do. Questions so far? This chapter is, I think, easier than the last chapter. However, it is incredibly dry. It's pretty much just playing around with numbers inside of square roots. Numero 5, square root of 192. Now, if I were you, I'd look at 192 and go, you know, off the top of my head, I'm not really sure what the biggest perfect square I can take out is. A lot of times what I like to do is divide by 4 when it's an even number. and see if it goes in evenly. Ooh, so we can take out 4. Are there any perfect squares we can take out of 48? Another 4. Are there any perfect squares we can take out of 12? Another 4. And then that leaves me with 3. So if I can take out 4 3 times, essentially I've got this times this times this times this. So square root of 4 is 2. Square root of 4 is 2. Square root of 4 is 2. Square root of 3 is left over. And we get what radical 3? 8 rad 3.
You could also just use 16.
Oh, bigger. 64.
Yeah, 64.
So if I didn't want to do this, I could take out 4 times 4 times 4, or 64, and just break it up that way as well. So notice that breaking it up as 64 and 3, or using my calculator to break it down by little perfect squares, both will get you to the same answer. So that's kind of nice because you have some freedom. You can use big perfect squares, little perfect squares. You just need to make sure that there are no more perfect squares that you can take out of your final radical. 3 is prime, no perfect squares we can divide out. That's how we know we are done. So on your own, no, not on your own, let's go ahead and look at number 6, which I'm going to say is square root of 400. Are there any perfect square factors that be jumping out at you? 100. And 4. What's interesting about both of those? They are both perfect squares. So the square root of 100 is 10. Square root of 4 is 2. What operation is going on between those two? Multiplication, so 20. So if my factors were both perfect squares, what does that tell me about 400? It is a perfect square. So I actually could have done square root of 400, which is second x squared, 400. And I could have gotten 20 that way. So if the number itself is a perfect square, you can just use your square root. So now we're going to take it up a slight notch. 2, radical, 125. What is different about this one compared to the other ones? There is a square root, but a coefficient already out in front of it. So I still try to take the biggest perfect square, factor out of 125. Any guesses? Let's try 25, and that leaves me with 5. So the 2 continues to float out in front. 125 breaks down into 25 and 5. So we broke up the radical. So then 2 times 5 times radical 5 is 10 radical 5. I want you to, wherever you have space, do this final problem. 3 square root of 108. See if you can simplify that one. Grab your calculators and try to find the biggest perfect square you can take out, or just keep breaking it down by little perfect squares. Hmm? Check it on your calculator. Try doing 3, then second x squared, kitty corner from your 7, 108, under the square root, and check what you got. So there's the nasty radical that we start with, and when I simplify it, 18 radical 3, same nasty decimal. So there's your answer, 18 square root of 3. Raise your hand if you got that right. So what I did with the 108, it's even, so I tried dividing it by 4. Then we see we have 27, which I can take a 9 out. So I broke it down by small perfect squares, and then I simplified each of those into 2 and 3. So keeping in mind that these are joined by multiplication and showing all of that lovely work. So,
wait, yeah, I got 6 square root of 27.
Oh, if you got 6 square root of 27, can you simplify 27 further? 9 and 3.
I have 11 square root.
I think you added the 3 and the 3 and the 2 together instead of multiplying them. Because 3 plus 3 plus 2 would be 11, but we want to do 3 times 3 times 2.
You can also like do that for like 2.
Oh, you're right. Yeah.
Okay, so folks, that's kind of our little intro to simplifying square roots. And in this unit, it kind of starts similarly to the last one where we're going to do operations with radical expressions. Up at the top of this, I want you to write, I can do this. And draw me your happiest face. Yep, those teeth look horrifying. Well, I tried. Did my best. I can do this. I can try this. All right, folks. So in this section, we are going to, I think today, just do the adding, subtracting, and multiplying and just basic simplifying of radical expressions. Tomorrow is when we will get into dividing. So just like in the last unit, we had multiplying and dividing, which were easier types of operations, and then adding and subtracting were harder. Here, the dividing is kind of the hardest thing that we do with radicals. So our big goal with all of these problems is we always want to simplify first. So now we are in the first page of our notes. Simplify first. So looking at problem A, I have 2 separate radicals separated by subtraction. Now if I tell you simplify first, take a look at the square root of 98. Are there any perfect squares we can take out?
Well, maybe. We don't know.
Well, we might not know. So let's try dividing it by 4 since it's even. Nope, that didn't work. It is even if I try dividing it by 2. Ooh, 2 and 49. That's another strategy. If it's even and you can't divide it by 4, try just doing a basic factor tree and see if any perfect squares arise from just finding the other non-perfect square factors. So 98 can break down into the perfect square factor of 49, and then the 2 is the non-perfect square factor. So then the square root of 49 is 7. So 7 rad 2. So I have simplified that first radical. Now we look at our second radical. Now this one already has a coefficient on the outside, -2. Not going to do anything with that at this point. I'm just going to focus on simplifying the square root of 32. What's the biggest perfect square we can take out of 32? 16. And then 2 is our regular factor. So, bringing all our work down, we've got the -2 still out in front. What operation is going on between the 2 and that square root? Multiplication. So I'll have 2 times 4, evaluating the square root, and then square root of 2. Now when I simplify this next part, -2 times 4 is -8. So I have 7 radical 2 and a -8 radical 2. So up till this point, it's things that we have been doing with the quadratic formula. We've simplified the square root itself. Now we get into the operation aspect. I want you to write by adding and subtracting. We can only do this with like terms, which means like radicands. Say it with me, radicand. Like radicands. Can only add or subtract with like terms, which are like radicands. So, to show you what I mean by this, if I had, let's say 2x plus 3x plus 4y, which are my like terms? 2x and 3x. So when I add these, if I have 2 of something plus 3 of something, we have 5 of that something. And then plus 4y. So if I do this same thing with radicals, if I have 2 rad 7 plus 3 rad 7 plus 4 rad 5, the radicals behave like units. I have 2 rad 7 plus 3 rad 7s. How many rad 7s do we have? 5 rad 7s. And then what about 4 rad 5? Can I add those together? They are not like radicands, so they are not like terms. So sometimes you'll have binomial or even trinomial expressions. We can only add like radicands, stuff under the radical, together. So let's go ahead and just go into the blue sheet again. Or actually, no, let's go ahead and finish A. Thank you. So if I have 7 rad 2s and -8 rad 2s, how many rad 2s do we have? You can say -1 rad 2, or you can just say negative rad 2.
What if they both want 2?
Then you would leave it just like this example up here.
Oh, no. So it has to be like terms?
Yep, got to be like terms, got to have the same radicals to be able to add them. So you could have this, or you could have this. Having a negative radical 2 is the same as having a -1 radical 2. All right, folks, so let's go to the blue sheet. And I want you to try number 1. Work with a friend. Ask them how their break was. Ask them how they're staying motivated in these trying times. Oh yeah, when's lunch?
It was fine. It wasn't horrible. It's I think my so I was doing cups, right? Which means I scan up front.
No,
I
the
had
car
like
dead
paper
battery.
sheets that have like a QR code and you make cups. Yeah.
I need to get my car jump started.
It wasn't bad. It was hard because I would have to get everyone's QR code.
Let's go.
Is it
If
15
he's
square?
reached from upstairs in
Right.
science, but they don't reach from downstairs in math. Science is like
That's showbiz, baby.
They'd be like, I know everything.
Yes.
I don't need a QR code. You're
Is
fine,
it
bud.
15 square root 5?
Okay, big guy.
Was it the same guy?
yeah. I get out to take it out.
Yes, we. Wait, no.
They changed it.
No, but
Ain't no way we get out.
4:15. You got 3 minutes.
No, 12:30.
The bell won't ring when we
why
get out.
did you 12:30 come back up here?
Advisory schedule.
Come on. Come on, buddy.
Here, folks, we're gonna go ahead and talk through this one. So, starting with the first radical, what's the biggest perfect square we can take out? So the perfect square factor is 4. Non-perfect square factor is 5. So then we have 3 times 2 rad 5. Is it 5 rad 5 or 6 rad 5? 6 rad 5 for the first radical. Now we simplify the next radical. We've got that coefficient of 3. How are we going to break down 45? 9 is the biggest perfect square factor. 5 is the non-perfect square factor. So 3 times 3 rad 5. You don't have to show all of the work, but you got to show some of the work. You're not just going to copy down the answers for this. You have to at least show me how you are breaking down those radicals. So we got 9 rad 5 and 6 rad 5. Are those like radicans? Yep, so I will be able to add these two together to get 15 rad 5. And you don't have to do that at this point. You can wait until the end. Let's see what happens with our other radical. This is negative 2. Biggest perfect square I can take out of 40. 10 and 4. 4 is the perfect square. 10 is the non-perfect square. So negative 2 times 2. Remember, these are multiplying, so that gives us a negative 4 rad 10. Am I going to be able to add negative 4 rad 10 to 15 rad 5? No. Nope. So that is our final answer. Now, could I check myself on my calculator?
Yes.
I can for accuracy. Your calculator will tell you if what you started with is the same as what you ended with, but it will not simplify the radicals for you. Does that make sense, how we can check it?
No. Can you do it?
So, 3 square root 20. Arrow over to escape the radical. 3 square root 45. Arrow over to escape. Oop, I forgot the 3 in front. 3. And then minus 2. Square root of 40. So that's what that whole expression is equal to. Nice and irrational. If I type in my simplified answer, it should be equal to the same thing. We're not changing the value. We're just simplifying the expression to make it look better. And as you can see, what we started with is the same as what we ended with. So it's not a great way of checking. It's not going to tell me if I simplified stuff all the way, but it will inform me if I have made an accuracy error. Capiche? Capiche. All right, folks, getting after it. We're going to go back into the notes. And now we're going to look at our next operation. What operation is going on here? We've got multiplication. We've got addition. We've got subtraction. Now, the first thing we want to do,
Is listen to Miss Cairo teach.
thank you, is simplify first. Duke, simplify first. Can we simplify any of those radicals?
No.
That's enough. So, no simplifying to do there. So now we are ready to multiply. How many things do I have in this expression?
4.
There are 4. So even though this first thing has a coefficient and a radical, that is one chunk, this is one chunk, that is one chunk, and that is one chunk. So how do I multiply these together? We FOIL, thank you. So first times first. Now when we multiply, this is our little rule, you are going to multiply the coefficients and multiply the radicals and then simplify if you can. So it's kind of like you're multiplying like stuff together. So when I multiply these first two chunks, 4 times 3 gives me 12. What's radical 3 times radical 2? Radical 6. Where students get confused is they will try to FOIL these two expressions. They'll try to take 4 times 3, then 4 times rad 2, then the rad 3 times 3, and then the rad 3 times rad 2. We are only multiplying like stuff together. So this is our F part of FOILing. Now we move to the O part of FOILing. Outside box times outside box. Making sure that you know where I'm actually going to box that in. That's a negative 6. So 4 rad 3 times negative 6 will give us a negative 24. What? What do you can do first or front, outside, inside, last.
I didn't know it actually stand for something.
It does stand for something.
Oh my word.
The more you know. Welcome to turn 2. All right, folks, so first times first. Now here, there's no radical associated with that negative 6. So what's going to happen to that negative 3? It's just going to stay in radical 3. Inside terms. We multiply our coefficients. 5 times 3 is 15. Radical 2 times radical 2 is?
Radical 4.
Radical 4.
Do you leave it like that? Or?
We are not going to leave it like that, but we're going to leave it like that for now. We're going to do our last product. 5 rad 2 times negative 6. Negative 6 is a coefficient, so negative 6 times 5 is negative 30. And then the rad 2 on the end. So now that we've carried on, we'll see if we can simplify. Can I simplify 12 rad 6? No perfect squares we can take out of 6. Can I simplify negative 24 rad 3?
No.
Positive 15 rad 4? Yepers, that's a perfect square. So this is going to turn into 15 times 2, or 30. Can I simplify negative 30 rad 2? No. So bringing down what I have, 12 rad 6 minus 24 rad 3 plus 30 minus 30 rad 2. Can I cancel out those 30s?
Yes.
No.
No.
Why not?
Because
Not like terms.
They're not like terms, so sometimes students will be like, but they're the same. If you had 30 minus 30x, can you simplify those?
No.
No. Now sometimes students will look at that and go, should I be like trying to take out a GCF? Folks, we are not factoring here. We are not simplifying. We are not simplifying by factoring. We are just simplifying it all to be on the outside, all to be one expression. So this ugly thing is our final answer. We can't simplify it further because they are all different radicands. So sometimes you'll be able to simplify a lot. Sometimes you won't be able to simplify much at all.
Did you order it? Like, what you do with, like,
That's a good question. Does the order of these matter? Folks, for checking yourself more easily on the answer key, leave it in the FOILed order. There's no like, hey, put your single coefficients first or put the radicals in descending order. There's no standard form for these, so just leave them in the form that you operated with. Great question. More questions? Blue sheet time. Number 2. Work with a friend. Work with an enemy. See if you can get to the same simplified answer. Check for any simplifying first, and then carry out the FOILing. okay.
In a second. Say pizza time.
What?
She won't say pizza. Say pizza time.
Pizza time.
Exactly. Now Daisy, you do.
Who?
Can you tell Daisy to say pizza time?
No. What is pizza time? Isn't that from Teenage Mutant Ninja Turtles?
Spider-Man.
No, it's.
Oh wait, yeah, that is a Spider-Man meme. That's oh, which Spider-Man was that?
It's an original joke. It's an inside joke between me and Daisy.
What you didn't have, you two here.
Daisy, you can
Sideways,
throw
and then two here.
Oh, got him.
My huh?
I felt bad.
Oh, jeez.
Say pizza time.
All right, folks, check yourself. How'd we do?
Huh, I got it right.
Hey, easy.
You do it on me first, bro.
Folks, can we simplify this any further?
No.
No. Final answer. In your homework packet, I'm going to give you some work time to do the following problems. I want you to try number 10, 11, 12, and 13. Go! Number 11, number 12, number 13, and 19.
Guido,
And
Usar,
10.
Albino.
C.
7, 11, 12, 13, 19.
10, 11, 12, 13, 19.
If I ask Jess to say pizza